All right, so in this video, we're going to summarize everything we went over September 30th on Wednesday. A couple of general announcements to start. You took a quiz last Friday on September 25th, and that grade will be released to you on Thursday tomorrow. Right, so you'll be able to see all your incorrect answers, your correct answers, and complete your retake by Thursday. And then a reminder that I asked you to vote because I'm going to take a mental health day on Friday, and you suggested that we do Thursdays and Fridays lesson, both on Thursdays. So Friday will be all asynchronous, no Zoom lessons on Friday. So our learning goal for today is to talk about something called average atomic mass. Right? So far, we know that in the periodic table, right, that the mass of an atom or an element is made up of protons plus neutrons together. But it's kind of weird because here, our bottom number, this represents the average atomic mass. So you might wonder, why is the average atomic mass of two elements end up with a decimal when protons and neutrons each weigh a whole number of 1? Okay, so that's what we addressed today. So on your Schoology page, if you go on to, doesn't matter which period, but if you go to today's folder, where it says September 30th Zoom class links, there should be a link that's titled Link to PhET. So if you open that up, it will look like this. All right, so you're not going to click on isotopes. Rather, you're going to click on where it says mixtures. All right, and there's a couple things I would like you to change. So on this bottom button below the box on the right-hand side, go ahead and click the scroll bar. Right. And I basically want you to play around with this tool. So notice that there are two types or two isotopes of hydrogen that exists. Hydrogen 1 represented by the purple circle, and hydrogen 2 represented by the green circle. Right? And you're going to move these toggles and notice what's happening to the average atomic mass number in this yellow box on the bottom right-hand corner. And specifically, as you're moving these toggles, I want you to answer 3 questions. First, what do you notice happen to the average atomic mass if each isotope is set at 50 and 50? So here, if this number was 50 and this number was 50, what happens to the average atomic mass? Secondly, what will happen to the average atomic mass if you have more green isotopes? So what if you have tons of green isotopes, not a lot of purple ones? And thirdly, what will happen to the average atomic mass if you have more purple isotopes? So the reverse of this, what do you notice? Right, so feel free to pause the video, and then I'm going to go over what happens next. Okay, so let's say we notice that they're at 50-50, meaning that we have the same amounts of both. So here, if you have the same amount of both, notice that the average atomic mass, average meaning like the mean or middle between the two, right? When I'm comparing these two, right? Here, our average atomic mass is a number that's split between the mass of the purple hydrogen, hydrogen 1, and the green hydrogen, hydrogen 2. It's exactly in half, right? So what happens if we have more green isotopes? Well, if I increase the amount of green isotopes and decrease the amounts of purple ones, you'll notice that it'll shift, the average atomic mass will shift towards the green isotope, right? So you might notice a little pattern here. So what if the opposite happens? Right, so that's question number 3. What if you have more purple isotopes? What will happen to the average atomic mass? Well, it'll shift towards the purple. So depending on which isotope is more common or abundant, whichever isotope you have more of, the average atomic mass will be closer to that number, right? Okay, so I'm going to skip through these slides because we just went over it. So here, if the average atomic mass of hydrogen is 1.008, do you think there will be more purple isotopes that have a mass of 1 or more green isotopes that have a mass of 2? Go ahead and pause this video and unpause when you think you've got it. All right, so hopefully you notice that, hey, my average atomic mass, this number is close to 1. And this mass is closer to 1. So therefore, this hydrogen is more abundant or more common, meaning that there's a lot more of these isotopes of hydrogen in our world than this one, right? Because our average atomic mass is closer to this one, right? And let's see if that's true looking at our PhET model, right? So on this site, if I change this to nature's mix, you'll see that 99% of the isotopes are hydrogen 1, right, as shown in purple. And there's only less than 1% that have a mass of 2, right? So because the average atomic mass is closer to hydrogen 1 is going to be more common. All right, so then we talked about the definition of average atomic mass and how we actually calculate this. So at this point, I released the class to go on to their Nearpod lesson 3.7. Right, so since this is no longer Zoom class, to find your Nearpod lesson or your homework, you're going to go ahead and click on this one under the September 30th Wednesday class materials folder, homework topic 3, atoms versus cancer, lesson 3.7. When you click on it, the Nearpod lessons are located here. You're going to make a copy of this document, and this will be your practice, right? Notice that you only need to complete 4 problems. So we can do questions 1, 2, 3, 4, and just make sure you're definitely able to do those. Right. Okay. So the other thing you need to do is after you make a copy, you need to upload a copy of this document in order to submit it. Thankfully, Mr. Ta has made us a video to show you how to do that. Right. So if you're like, Ms. Kwan, I don't know how to upload or make a copy of a document, please watch this video underneath this step in order to learn how to make a copy of this document and then upload it onto Schoology. So that's pretty much it for September 30th, Wednesday.